All right, this is section 2.4, pre-calculus, and we are on page 12, and we're going to be dealing with the complex number and reviewing all the operations with them. All right, the first thing that we're going to look at is so the imaginary unit I. It'll be italicized, and what it is equal is to the square root of -1. It allows us to simplify negative roots and to find solutions to our polynomials that are not real. We cannot take the square root of a negative, so we use this as a replacement. All right, first of all, here's what we know. I is the square root of -1, so I squared would be the square root of -1 times itself, which is equal to -1. All right, what we're going to do now is look at a pattern here. Let's just see if we can try to evaluate some higher powers of i's. So we already know the first two here. I to the third would be the same as I times I squared, which is I times a -1, which is equal to -I. I to the fourth, I can replace that with I squared times I squared, which I squared is equal to -1 and times itself. -1 times -1 is 1. I to the fifth could be replaced with an I to the fourth times an I. We know that I to the fourth is 1, and 1 times I is equal to I. I to the sixth can be replaced with an I to the fourth times an I to the second. We know I to the fourth is 1, and I to the second is a -1, which equals -1. I to the seventh could be I to the fourth times an I to the third. This equals I to the fourth is 1 and I to the third is -I. Multiply those together, you get -I. And let's do one more. I to the eighth can be I to the fourth times I to the fourth, which equals 1 times 1, which is 1. All right, so we go through all of these. Let's just see what we've got here. We've got I, -1, -I, 1, I, -1, -I, 1. It repeats. If you break these into groups of 4, these first 4 repeat in the second set of 5 through 8. So here's a conclusion that we can make, is that this always will repeat. So those are the orders, I, -1, -I, and 1, and we can use that to find higher exponents. It'll always go in this order, I, -1, -I, 1, for every multiple of 4. Operations with complex numbers. We are going to be able to basically just add like terms. If this is a complex number right here, a plus bi, and c plus di, well, the a and the c are like terms, a plus c, and the bi and di are like terms, b plus d. You're just going to be adding like terms. Let's do the operations here. 6 plus 1, 7, and then -3i combined with 2i is -I. That is my solution, or my answer to the sum of those two complex numbers. In subtraction, you have 5 minus 2, so 3, and -I minus a negative, that would be plus a positive, so plus 3i. That's my solution to that complex, the difference of. So these operations are just adding like terms, and we're also going to be looking at doing some other operations like multiplication in example 2 here. So we're just going to distribute. That's 34 minus 10i. On letter B here, when you've got the square root of negatives there, you're actually going to want to replace each one individually. The square root of -4 would be 2i. And the square root of negative 16 would be 4I, because the square root of negative, you replace it with I. It's like this, the square root of 4 times the square root of a negative 1, and it goes the same for the square root of 16 times the square root of negative 1, and you replace those. Anyway, this is 8I squared, and since I squared is equal to a negative 1, my final answer is 8 times negative 1, or negative 8. I'm sure you remember all these operations from Algebra 2. So letter C, we're going to FOIL. 3 times 5, 15. 3 times 4I, that's 12I. Negative 5I. And minus 4I squared. You're going to want to replace all of the I higher powers with their equivalent. So you have 15. I've got plus 7I. And minus 4I squared would really become plus 4, because the I squared is a negative. Final answer is 19 plus 7I. That's how you're going to write it, is in the complex form. Complex form. So your numbers first, your imaginary unit is second. 1 plus 7I squared, you need to write this as 1 plus 7I times itself, and actually go through and FOIL this. This would equal 1, you have 7I twice, so that's 14I, and plus 49I squared. 49I squared would become minus 49. 1 minus 49 would equal negative 48 plus 14I. That would be all of our solving there. Let's go ahead and FOIL the bottom here. 4 times 4, 16, minus 20I, plus 20I, and minus 25I squared. All right, the 20i's cancel. The minus 25I squared really becomes, this is plus 25, so 16 plus 25 is equal to 41. So those are some basic operations. We had addition, multiplication, subtraction, maybe some distributive property, FOILing. Now let's take a look at what happens when we are going to division. Let's divide. Complex conjugates are two complex numbers in the form of, you have an A plus BI and then an A minus BI. So together they're called complex conjugates. Here's how their products, or this is what their products give us. You have A squared. The two middle terms, minus ABI plus ABI, they will always cancel. These middle terms will always cancel. So you have minus B squared I squared. Well, what we know about the I squared is that it will change the sign, so it's A squared plus B squared. That's the result of multiplying a number times its complex conjugate. All right, we use that in the sense of being able to simplify our expressions when we have i's in the denominator. You're familiar with this by doing our rationalizing. If I'm trying to simplify this, I need to multiply the top by its conjugate. And we are going to distribute, and the bottom by the conjugate. On top, when I distribute, I get 2 plus 2i. On bottom, I get 1. The middle terms cancel because they're conjugates, minus I squared. So this is 2 plus 2i over 1 minus negative 1, or 1 plus 1, 2, and then you can divide and get 1 plus I. That is our simplified answer. You can never leave an expression that has an I in the denominator. On this second one here, you're going to have to take and multiply by 4 minus 3i. That's the conjugate. That is going to allow us to cancel the i's in the bottom of our fraction. FOIL the top. You got 8 minus 6i minus 4i plus 3i squared over 4 times 4, 16. The middle terms cancel. You have minus 9i squared. We get, as a result, 8. The plus 3i squared right here, this plus 3i squared becomes minus 3, so we have 5, and then minus 10i over 16. This right here becomes plus 9, so 25. You can reduce them all by 5s, so we would have 1/5 minus 2/5 I. And I write that in that form because that's how complex numbers should be written. Okay. All right, that's how you simplify your denominators. The next thing that we're going to do is just work on some higher exponents. So how do you simplify when you've got a little bit substitutions to do, like with I to the third or fourth? All right, we've got 4i squared. So this is 4. I squared is a -1 minus 2, and I to the third is a -I. Here's my list again. It starts out as an I, then it goes to -1, and then it goes to a -I, and a +1. That's what repeats, the 1 through 4 there. All right, this becomes -4, then plus 2i. All right, we got -48 underneath the square root symbol, and then all of that is to the third power. Let's take care of the negative. You've got the square root of -16 times the square root of 3, all of that. I'm just trying to simplify my root to the third. So that becomes 4i square root of 3 all to the third. 4i to the third would be 64 I to the third, and the square root of 3 to the third is 3 square roots of 3. So final answer, 64 times 3 is 192. I to the third is a -I, and we still got this square root of 3, so -192 I square root of 3. That was a doozy. Keep simplifying and substituting what you know. You can't have any i's in the bottom of this fraction here, but let's go ahead and simplify what we have. 1 over 2, and this would be a -I. So I'm going to have 1 over -2i. We will multiply top and bottom by I, and you get I over -2i squared. This becomes I over, we actually should, in your packet here, this is in parentheses, the 2i is in parentheses, so that would become 8 instead of 2. So -8 here, -8. That would become 1 over 8, or I over 8. Because I squared is negative, it changes the 8 to a positive. All right, the last one, I guess what you'd want to do is, knowing that it keeps repeating every 4. So if this was a multiple of 4, so we know I to the 40th would be 1. So 1 before that, I to the 39th would be, or you can also know it because it's a multiple of 3, it would be -I. -I is my answer on that one. The last thing that we're going to do is do some plotting of points. When you plot points into the complex plane, you just basically rewrite your x and y coordinates. Each complex number corresponds to a point in the complex plane. You transform the rectangular coordinates of xy into ABI is basically what we do. So your x becomes your A value, your y becomes your BI coordinates. So your x and your y-axis is your imaginary axis. And what we're going to do here is we're going to plot these points, and then we'll be done. So this first number, the 3, is an x. So you go over 3, and then 2i is up 2, right there. This is 3 plus 2i. So this becomes a BI axis, and this is your A axis. 3i would be as if you had 0 plus 3i. So just up 3. This is 3i. Negative 4 is just to the left, 4. It would be like having negative 4 plus 0i. And the last one, negative 1 minus 3i, left and down 3. This is negative 1 minus 3i. That is how you plot points. And that concludes our section 4. There is your assignment.